This lecture is on some fundamental trig identities. Make sure that you've printed off the worksheet so that you can follow along as I go through the video. Let's begin with our basic trig identities. These are some that we have already worked with. You should remember that cosecant x is the same as 1 over sine x. Secant x is the same as 1 over cosine x. Cotangent x is the same as 1 over tangent x. Those together are known as the reciprocal identities, and that's because I'm doing 1 over another function. The next two, tangent x is the same as taking sine of x and dividing by cosine of x, and cotangent is the same as taking cosine of x and divided by sine of x. These two together are known as the quotient identities because they are the result of dividing two functions. So as we go to the bottom, we're looking at how do we prove basic trig identities. Make sure you've also printed out the advice for verifying trig identities because those will help you, give you some strategies to work with. These are not the type of problems that are step 1, do this, step 2, do this. It really is like a puzzle, and you have to try your best to solve them. If you pick up a piece of a puzzle and it doesn't fit, you just have to remove it, put it back, and grab another piece. Verifying trig identities are the same way. So in starting with this first one, what we want to do is start with the more complicated side. Sine x, secant x looks a lot more complicated than tangent x. So we pick a side, we simplify just that side to make it look like the other side. So what I'm going to do here is actually go ahead and bring down equals tangent x equals tangent x. I don't know how many steps we need, but I'll start with just those two. Because we're not going to touch that right side, we're only going to work with the left-hand side. So sine x has no other form other than sine x. Secant x, however, can be written as 1 over cosine x. So this is sine x times 1 over cosine x. I've just substituted secant for 1 over cosine. Now I can rewrite this as sine x over cosine x. Well, from our from our quotient identity up here, we know that sine x over cosine x is tangent x. So I can go ahead and rewrite this left side as tangent x and bring down the right side as tangent x. Now I have the left side equaling the right side, and I'm done. Again, notice that I only work down one side of this equation. I cannot go from side to side. Only down one side. You choose that side in the beginning. If it doesn't work for you, you start over and you try something else. Moving to the next one, I have tangent x equals tangent x times cosine x divided by sine x, and I want to show that that equals 1. This is definitely the more complicated side. 1 is as simple as 1 is going to get. We'd only make it more complicated by trying to change it. And so let's start. Let's go ahead and bring down 1 equals 1 equals 1. It may take 3 steps to do this. Let's take a look. First, I know that tangent can be written as sine x over cosine x. So I've just replaced that. And I'm multiplying that by cosine x. All of that is my numerator. Then in the denominator, I'm dividing everything by sine x. Okay, let's take a look at what can happen. I can think of this cosine x that's by itself as cosine x over 1. Then at that point, the cosine that's in the top left denominator can cancel with the cosine that's in the top right numerator, and I'm just left with sine x over 1. This can be just simplified to sine x over sine x. Notice that I've brought these ones down. I'm not focused on the right side at all. I'm focused on making the left side look like the right side. Well, what's sine x divided by sine x? Anytime we divide something by itself, what do we get? Hopefully you thought or said 1, and so this becomes 1, and we are done with that identity. Let's move to the next one. Again, I'm going to go ahead and bring down equals secant x equals secant x equals secant x. It may take 3 steps, it may take more, it may take less. I just wrote it 3 times for clarity's sake. Now on the left hand side, I have cosecant x over cotangent x. Well, cosecant x is 1 over sine x. And in the denominator, cotangent x is cosine x over sine x. If you remember rules for dividing fractions, we actually multiply by the reciprocal. So I can rewrite this as 1 over sine x times sine x over cosine x, which is the reciprocal of cosine x over sine x. Now what can we do? Just as in the last problem, I can cancel sine x with sine x. I'm left with 1 over cosine x. Well, 1 over cosine x, according to the reciprocal identity here, is the same as secant x. So I can write this as secant x. And if I bring down that right-hand side, I still have secant x on the right-hand side. And so I can see that that is also an identity. At this point, if you're having trouble with fractions or identities, I challenge you to try these out and look at cross-dividing or cross-simplifying, as well as dividing by the reciprocal when you have, multiplying by the reciprocal when you're dividing fractions. So pause the video, take some time to try these out, and when you unpause, you'll see the answers. So make sure you're really working them out, because otherwise you might have questions about how did she get that. Okay, here are answers for those. If you have questions about those, make sure you're asking Miss Massey or Miss Walls tomorrow in class. What else can I do with fractions? With these examples, in the first one, I'll work with the left side to make it look like the right side. In the second one, I'll work with the right side to make it look like the left side. So I know secant x is the same as 1 over cosine x. So I have 1 over cosine x plus sine x. And I want this right side to stay the same. So I'm going to keep this as 1 plus sine x cosine x over cosine x. And then I'm going to transform the left side in order to make it look like the right side. Now notice the denominator of sine x is 1. And so whenever we're adding fractions, I need a common denominator. So my common denominator here is going to be cosine x. Now the left fraction is already over cosine, so I don't need to do anything to it. I can just rewrite it as 1 over cosine x. The right fraction, on the other hand, will need my help. I'm going to have to multiply both top and bottom by cosine x so that I get that same denominator. So the right fraction becomes sine x cosine x all over cosine x. Now what's really neat about fractions is once I have the same denominator, then I can add the numerators together, keeping that denominator. So the left side is now 1 plus sine x cosine x all over cosine x. And notice that that's exactly what I have on this left-hand side. So I'm just going to rewrite the right-hand side, copying it down from the original problem. I'm not changing it. I'm not trying to change it. I'm just bringing it down because I've already changed the left side to look exactly like the right side. So I have verified this identity. Now with the second example, I'm going to work solely with the right side and try to make it look like the left side just to give you a different perspective. So I'm going to go ahead and just copy the left side down. Cotangent x plus secant x. And a couple more times. Cotangent x plus secant x and cotangent x plus secant x. That's where I want to end. But I'm going to work with this right-hand side to see if I can get there. Now notice that this is a binomial, two terms added together over a single denominator. There are rules that allow me to split up the terms of the numerator and place them over the denominator, which is the opposite of what we did over here to the left when we combined them. So when I rewrite this, I have cosine squared x over sine x cosine x plus sine x over sine x cosine x. And now that they each have their own denominator, I can do some simplifying. I cannot do it while they're together, but if they've been added, I can certainly split them apart through addition and keep the denominator the same. So now when I simplify, I can cancel cosine x in the denominator with one of the two cosine x's that's in the numerator, leaving a cosine x in the numerator. That's all I can do on that left-hand side. On the right-hand side, I can cancel the sine x in the numerator with a sine x in the denominator. Now I have cosine x over sine x plus 1 over cosine x. Well, what's cosine over sine? Hopefully you said or thought cotangent. So that's cotangent x. And what's 1 over cosine? Hopefully you said or thought secant. And so that's secant x. And so now this identity has been proven as well. Now take a few minutes and calculate sine squared pi over 3 plus cosine squared pi over 3. Pause the video, let me know what you get. Hopefully you got 1. Try the second one, sine squared 2 pi over 3 plus cosine squared 2 pi over 3. Pause the video, take some time to work that out. You should have gotten 1 as well. So this leads us to something that's really cool. Remember that we created the unit circle through right triangles, and the unit circle has a radius of 1, which ends up being the hypotenuse of those right triangles. So for any angles that we can find on the unit circle, it's always going to be the case that sine squared plus cosine squared equals 1. So how did that happen? Well, for any point on the unit circle, x squared plus y squared is 1. That's our Pythagorean theorem. And we know that x represents cosine of the angle and y represents sine of the angle. So if we combine those, then we can get a Pythagorean identity, which is very common and one that you will use a lot. And the way that we're going to write that is that cosine squared theta, that could be x as well, plus sine squared theta equals 1. And that will always be true. Now, we can use this to get two other identities. If we divide everything by sine, then cosine squared by sine squared, then cosine squared divided by sine squared, well, that's cotangent squared. And sine squared divided by sine squared is just 1. And then 1 divided by sine squared is cosecant squared. So that leads us to another Pythagorean identity. And then if I take this same original cosine squared plus sine squared equals 1, and this time divide by cosine squared. So cosine squared divided by cosine squared is 1. Sine squared divided by cosine squared is tangent squared. And then 1 divided by cosine squared is secant squared. So the main trig identity is the first one, cosine squared plus sine squared equals 1. But you can derive the other two by dividing everything by sine squared or by cosine squared. You will have to know some of these. It says here that they're provided on the formula sheet during the exam. I'll have to work with Ms. Murphy and Ms. Massey to determine whether or not we're actually going to provide those for you. So for now, we'll work on memorizing the main one and making sure you understand how to get the other two from those. Let's see if we can work with these identities at the bottom to show that they're true. You may have to just think deeply. We're working on Pythagorean identities, so look for some things that we've already found. For example, this first one, we have cosine squared plus sine squared plus tangent squared equals secant squared. Well, we've already shown up here that cosine squared plus sine squared is 1. So I can rewrite this as 1 plus tangent squared theta. I'm hoping to show that that equals secant squared. Remember that I work going down, not across, so I'm not done until what's on the left side looks exactly like what's on the right side. And since I've chosen the left side to work with, I have to continue to work with that side. Now, we have an identity here that says 1 plus tangent squared is secant squared. Well, I think that helps us out a lot, because now we have secant squared theta equals secant squared theta, and we're done. Take a look at the next one. 1 minus cosine squared times tangent squared equals cosine squared. Seems a little odd. Well, let's take a look at it. 1 minus cosine squared. Tangent is the same as sine over cosine. So I can write this as sine squared x over cosine squared x, and hoping to show that that equals cosine squared x. Well, if I simplify like we talked about before, and then I can cancel cosine squareds, Then I have 1 minus sine squared x equals cosine squared x. Well, let's take a look. Cosine squared plus sine squared equals 1. What happens if I subtract sine squared from both sides? Then I get an identity for cosine squared alone. Cosine squared equals 1 minus sine squared. So that gives us enough to prove that this is in fact an identity. It's true for every value of x. We have one more example, but I'm going to move this one to a new page because I don't think I'll have enough room to try and finish it down here without sliding it all in. So we're going to scroll to a new page here. Okay, here we go. Now we have a little bit more room. I'm going to work from the left side, try to see if we can show that that equals the right side. So I know that cosecant x is the same as 1 over sine x. So I can write this as sine x minus 1 over sine x. This is sine x over 1. I don't have a common denominator, but I can create one. If I make my common denominator sine x, then that will force me to multiply both top and bottom of this left expression by sine x in order to get the new denominator. So then I'll have sine squared x over sine x minus 1 over sine x. And so what will that give me? Well, let's see. That gives me sine squared x minus 1 over sine x. Remember that cosine squared x plus sine squared x equals 1. And what I have here is sine squared x minus 1. So how can I get that? Well, I'd have to subtract 1 from both sides. But that also means that I'd have to move cosine squared x to the other side. So this becomes sine squared x minus 1 equals negative cosine squared x. So I can make a substitution of negative cosine squared x here. So this becomes negative cosine squared x over sine x. So how does it help me get to negative cotangent x cosine x? We have to be really creative in doing this. And we have to understand what it means to multiply things together. And so let me show you what we can do. I can think of this as negative cosine x times cosine x over sine x. So this is still negative cotangent x cosine x. And so then negative cosine over sine, I can just write as negative cotangent. That's what this part has changed to. So all of this became negative cotangent. And then that just leaves me with a cosine x. And that's exactly what I have on the other side. So that identity, again, has been verified. Now, again, I don't tell you that these are easy to do. You really must practice. You really must use your brain. I can do these problems over and over and over again, but until you practice them and actually get frustrated, it's not going to come to you any easier. So I hope you're watching this tonight, which is Wednesday, November 7th, because Mrs. Walls and or Mrs. Massey will be in tomorrow, Thursday, to help you out with these. And if you haven't watched the video, then you may have some trouble. So just continue to do what you're doing in class. Look forward to a midterm on Monday, and you'll be working with Trig Identities on Thursday and Friday. See you soon.